Okay, so it's 5 after, so I think we can just start properly. Um, so good morning or good evening, depending on where you are. Good afternoon. My name is Hayden Fennell. I am this year's workshop organizer, and I will be running us through our Python bootcamp today. So like I was saying, for anybody who just joined, the slide deck that we'll be using today is available at the following link. So if you haven't already set up a nanoHUB account, we'll walk through how to do that in just a minute. And if you have not downloaded and installed CompuCell 3D to your local computer, we highly recommend that you do that tonight. Make sure that it's running because we will not have a remote option for running CompuCell this year. We will be teaching just using local installations of CompuCell 3D. So if you have not installed it yet, please do try to install it tonight. And if you're having problems with your installation, please send me an email. Put my email in the chat here. I think everybody should already have it multiple times over at this point. But I will throw it in the chat. And then we will not have much time during the day to help with installation issues. But if you are facing a problem, we may be able to help you during the Q&A session at the end of the day tomorrow. So with that, just a quick look at our schedule for the week. This shortened version of the schedule is posted online. Today, we're in, again, day 0. Sorry, this should say Sunday, July 28th. I'll fix that and re-upload these slides at the end of the session here. But today will be 4 modules. We'll have an overview of Python basics, and then we'll look at sequence types in Python, different things you can do with lists and strings. We'll have our 90-minute lunch break, the first 45 minutes of that. If people have questions, we'll stick around to help answer those questions. Then we'll have 45 minutes of lunch break. Module 3 today, we'll go over dictionaries, functions, variable scope, and the concept of modules in Python. And then the 4th module today, we'll talk a little bit about object-oriented programming concepts with classes, attributes, and then we'll talk about some additional packages as well that will be useful, both for the workshop and for using Python more generally. So tomorrow, and we'll just blow through a quick overview. Tomorrow, we'll go over the basics of CompuCell 3D. We'll go over the logistics of the course first, basic overview of CompuCell. There will be a quick intro to virtual tissue modeling. We'll have some presentations from our presenters talking about different models that you can, or different models that have been published using CompuCell, to kind of give you an idea of the different kinds of things you can do with CompuCell. And we'll talk about basics and intro of the underlying algorithm that runs CompuCell, how to operate the CompuCell interface. And then we'll have a 90-minute session with a couple of different example simulation activities. Tomorrow we'll mostly be using CompuCell's player, and then we will start looking into the code behind the simulations on day 2. And we'll talk more about the rest of the schedule tomorrow. Again, we go through Sunday, the 4th. So we have 7 official days of workshop. And like I said, we'll go over this in more detail tomorrow. But these will be in the slides at the end of the day today, if anybody has any questions about anything coming up in the schedule. All right, one quick note about the hackathon before we get started on our content today. So just as a reminder, we will be having our model building hackathon 1 week after the workshop this time around. That will be from Friday, August 9th to Sunday, August 11th. There will be 2 official days of hackathon, Saturday and Sunday, and then that Friday beforehand, we'll meet in the late afternoon, early evening to finish off our teaming efforts, make sure everybody knows which team they're working with and what each team is doing. And then we will get started on the actual model building process first thing on Saturday. We'll be hosting a couple of hackathon project pitch meetings. So for the last 3 days of the workshop, during the extra session before lunch, there will be an opportunity to give some lightning talks about your hackathon idea. We'll also be hosting at least one longer hackathon teaming meeting in that week before the hackathon after the workshop. It's important to note here that you do not need to have a project idea to participate in the hackathon. We are happy to help you find a project group if you'd like to just join a group with an existing idea. Or if you feel like you might like to run a group, or even if you might like to work by yourself, we have a couple of sources where you can find some ideas if you don't have an idea of your own already. So for the lightning talks, these will be talks of 3 to 5 minutes each where you can pitch your idea. We'll have you prepare a short presentation. There's a template provided in the hackathon folder in the student materials drive that you can use as a guideline for your presentation. And then we will help either scope down your project, or if you have multiple ideas, we can help you select which one we think is the most feasible for a 2-day project. And then we can help with the teaming efforts as well. So if people, again, are not sure which group they'd like to work with, they can contact us and we'll help you find a group that we think best fits your skill set or what that group might need. And we'll talk in more detail tomorrow about the actual structure of the hackathon, and I'll be sending out a hackathon schedule document in tonight or tomorrow's evening announcements email. So do keep an eye out on your email. Each evening we'll be sending out emails with evening announcements after the end of the workshop each day, or workshop sessions each day. And then we'll also be sending out a morning announcements email at 8 a.m. each day that has the link for that day's Zoom session, as well as the link to the correct folder to go download and any other things that you may need to know going into each day. All right, so I think with that, we should go ahead and get started. So we have plenty of time to get through our first module today. So just a couple of notes on maybe why we want to learn Python in the world of scientific computing. The first and most obvious reason is that CompuCell 3D code is written in Python. So if you're going to interface completely with CompuCell simulations, it's important to know a little bit of Python going in. But Python is sort of rapidly becoming, what you might call an industry standard in a lot of scientific computing fields because of its ease of installation and ease of use. A lot of people are turning to Python as kind of the go-to language for scientific computing. So if you're interested in getting into the field of scientific computing, or if you're already sort of in scientific computing, learning Python never hurts. The way that we'll use Python throughout the workshop varies a little bit. So like I was saying, Python's simulation code, or excuse me, CompuCell's simulation code is written in Python. It also uses XML, which we'll talk about in tomorrow's sessions. But it primarily runs using Python code. And a lot of the add-on packages and plugin packages that you can use with Python are also written, that you can use with CompuCell are also written in Python. So understanding a little bit about how to use Python is pretty important in the world of open source scientific computing. So these 4 sessions today will teach us the necessary programming concepts to build, study, and analyze advanced models in CompuCell. So some of the concepts that we'll talk about today may seem a little bit basic if you've had some exposure to Python or to programming more generally in the past. But there's some syntax things, if you're not familiar with Python already, that will be important to pick up today before we get into the code later this week. So the idea today is that we're going to teach you everything you need to know about Python to use CompuCell, not much more and not much less. So some keys to success for kind of learning Python. So it's important to keep in mind that nobody knows everything about everything related to a programming language. There's always something new to learn, and each language is also constantly evolving. It makes it even more complicated. At least once a day, we will probably come across something that I don't know. That's okay. That's a normal part of the process. If you don't know something, the best approach is to look it up. One of the nice things about Python is that there's a huge open source community of developers and users out there that are constantly posting all over the internet about their issues that they've had with Python. So it's generally not too difficult to find somebody with either the same issue that you've been having or something similar enough that you can find the solution to your own problem. Now, one of the downsides of that is sort of a double-edged sword is that there is a lot of information about Python on the internet, so it's easy to go down the wrong rabbit hole sometimes if you don't know exactly what problem you're facing. So if you're facing issues today during any of the activities, please do speak up in the chat and we will help you as best we can with getting that solved. Another thing to keep in mind, solutions in programming are almost never unique. You can focus on what you want to do and how you want to do it. Each person will kind of approach things differently. There are some methods that are kind of considered more efficient than others, but for today's purposes, just program everything kind of the way that makes the most sense to you. We're not going to worry too much about efficiency of programming today. Today's focus is more on learning that kind of programming problem-solving process. And if you're feeling overwhelmed at any point, don't worry too much. Today is going to be a good bit of content, especially if you've never seen this stuff before. But like I was saying in previous slides, you don't need to know a lot of Python in order to use CompuSolve for this week. You just need to be exposed to some key ideas. That way, when they do come up over the course of the week, you've already seen them and you at least know what the terminology is. So don't worry too much. If you get a little bit behind today in some of the activities, it's not a big deal. Again, today is mainly a crash course to get you familiar with using the Python language more than anything else. All right. Yes. Professor Glazier has put in the chat that ChatGPT is a good way to maybe get some initial starting code if you're not sure where to start on something, but do keep in mind that because of the language or the nature of these large language models, it's not always correct, and you definitely need to test any code that you get from them before just dropping it into whatever you're currently building. All right, so first things first today, we're going to walk through quickly setting up a nanoHUB account and then finding the Jupyter Notebook app through nanoHUB. So we'll go to nanohub.org and hit login. So let me reshare my whole screen here and we'll walk through this together. So go ahead and open up your browser of choice. And you'll go to nanohub.org. And then up here, you'll click login. You'll need to create a nanoHUB account if you have not created one yet. We recommend, if you intend to continue using nanoHUB in the future, using an account that you will have persistent access to. So if you're planning on leaving your current institution anytime in the near future, maybe use a personal email to sign up. The process of changing your email account on nanoHUB is not as straightforward as some other platforms. So we recommend one that you will have persistent access to, not something that may expire within the next year or two. So I'll go ahead and log into my account. I'll give people a couple of minutes to get set up. Yes, if you're having issues with nanoHUB, you can also go to Google Colab, that's C-O-L-A-B. Google Colab is effectively the same thing as Jupyter Notebooks. You'll be able to follow along more or less exactly with Colab if you're not familiar with, or if you're not familiar with Jupyter, or if, well, we're going to teach you to be familiar with Jupyter today. But if you're having issues with nanoHUB, you can use Google Colab instead. All right, so next thing we need to do is open Jupyter Notebooks through nanoHUB. So for those who are unfamiliar with nanoHUB, nanoHUB is a computational simulation platform where people can host different kinds of computational modeling, either platforms or specific examples. And they have a Jupyter Notebook server that we're going to be using today. So if you're seeing this page, the home screen, you'll go up here to where it says logged in, and it should drop down your username and email. And then there's a button called dashboard. So we'll go ahead and click on dashboard. This is sort of the main search tool for how to find different tools in nanoHUB. Under the My Tools column on the right, you'll see I've run a few things lately, so it's got some stuff in my recent. The Jupyter Notebook we're looking for is actually right here, but in order to find it the first time, you'll go to All Tools. There will be a search bar, and in that search bar, you'll want to search for Jupyter Notebook, and that's Jupyter, G-U-P-Y-T-E-R, Jupyter spelled with a Y. You should see the list of applications narrowed down, and the one that we want is Jupyter Notebook 202105. You'll notice that there's these heart icons on the right. If you click the heart next to this 202105 Jupyter Notebook, that will add it to your favorites so that if you accidentally close nanoHUB, you can find it quicker next time. So we're going to go and click on that. This will take us to a splash screen for the nanoHUB Jupyter Notebook. And the URL for the one that we're looking for is here. I'll put it in the chat for people. If you're having trouble finding it in the search function, you can just follow this link once you've logged in. And I'll give people maybe 1 minute to get to this page. Once you get to the splash page, we'll click Launch Tool. May take a minute to initialize. We may take a couple minutes to initialize. So sometimes when we have a lot of people accessing the same tool at once, nanoHUB's initializations can be a little bit slow. So we recommend once you get into the Jupyter Notebook app today, just leaving it open through the breaks today. That way you kind of maintain that socket. It may still out over lunch, but you can always just get back in. So once you initialize it, you should see a file tree. I've already got some things in mind from previous use. Yours should be relatively empty if you've never used this before. But what I usually like to do is make a folder for each group. So let's go ahead and actually just delete this. Then let's make a new folder. So I'm going to go up to New, come down to Folder, and it will just make an untitled folder in your list. So you have to check it, come up here to the left to rename. And then I'm going to call this Python Bootcamp 2024. You don't have to make a new folder if you don't want to. I'm just doing this so that it's a little bit easier for me to find things later. I click through there. Now we'll use the same new dropdown. We need to create a new Jupyter Notebook. And we want to do that just using the standard Python 3.8 kernel. So the one without any parentheses behind it. We just want Python 3.8. So once you click that, you'll be presented with your Jupyter Notebook interface. So first things first, let's give this a title. up here. This works sort of like a Google document. You click on the title here. I'm going to name this to module 0-1. You can call it whatever you'd like. Just give it a name. And let me go ahead and split my screen here. Everybody see the split screen okay? See what that's looking like. Yeah. All right, so we've logged into nanoHUB. They've launched the Jupyter Notebook app. Again, these instructions are all in the slides. If you've missed a couple steps, you can reference them there. So what we're looking at right now is a interactive Python notebook. If you're unfamiliar with what these are basically just an interactive Python shell where you can write Python code in individual cells within the notebook and execute them kind of live in real time instead of having to go back and forth between editing a text file and then running it in the interpreter. We can actually just run individual commands here. We can also add markdown text and images around our code. We won't be doing much of that today. But basically, this just allows us to run small chunks of code independently so we can test things sort of very dynamically on the fly. When you're using a Python notebook cell, you can say, we'll type something in one line. If you press enter by itself, it'll give you a new line within the cell. If you press shift enter, it will actually run the cell. In this case, I'll get a syntax error because that's not proper Python code. But let's say I wanted to print this out. Go over print statements a little bit more in a minute. But when I hit shift enter, you'll see the output below the cell here. Are commands in Python 3.8 different from Python 3.10? No, nothing that we're doing today will be different between the two versions. And then can you repeat how to open a notebook? All right, got it. Good. Thanks, Keshan. Yeah, Sharon makes a good point. Later versions typically only add new features, particularly in the 3.x. So going from 2 to 3, there are a lot of syntax changes, but generally within any version of Python 3, the base syntax will be the same. It's mainly just adding new features with each .x version. All right. So we'll go ahead and move on into our first exercise. So one other thing, if you would like to save your notebook, so if you want to version your notebook as we're working, up here under File, so Jupyter will autosave for you in the current notebook as you work. You'll see up here, like in Google Drive, it says autosaved, so it'll save every 15 seconds or so. But if you'd like to version your notebook, you can come up here to click Save As to save a new copy and then continue working in that versioned notebook. Some other options here with save and checkpoint, but don't worry about those too much today. If you'd like to version, just use Save As. If you would like to go back to your notebook selection interface, you use this close and halt command. And what that will do is shut down the kernel and take you back to your notebook directory. And then you can just open the notebook you want from there. All right, so we're going to go ahead and actually get started with an exercise on using cells. So if you'd like to go ahead and do your hello world statement in cell 1. In cell 2, we're going to start with typing some expressions. So feel free to just follow along with me here. Again, in each cell, you can type expressions. So let's say we want to see what 3 plus 2 equals. We can just type that straight in, press Shift Enter, and you'll see we get output of 5. We can do more complex expressions, so we can do 5 plus 7 minus 8. And then let's divide that whole thing by 2. We do Shift Enter. You'll see we get 8.0. We'll talk a little bit about why we get that number in a minute. But maybe take just a minute or two to familiarize yourself with typing expressions into your Jupyter Notebook cells. And again, if you would like to print anything for now, you can use print and then a parentheses, and then whatever you want to print goes in between these quotes. We do have one question. Does nanoHUB/Jupyter require a restart session like Colabs does? So yes, you can restart the kernel if your code isn't getting executed. Sometimes, particularly if you've been working in a notebook for a long time, cells can start conflicting and things can get confused. So there is the option, if you go up to kernel, to restart and run all. Generally speaking, though, you don't need to do that when you're opening a new notebook and working in it. The Google Colab restart kernel is mainly if you're opening a existing notebook that tries to populate a bunch of stuff at once. So you do have the option of restarting the kernel, but you shouldn't have to do that today. All right, so I have a little problem here. Given 2 positive integers, a and b, you can choose the values. What is the corresponding sum of a and b? And then you could also use these other mathematical operators to do different things. So you can also do 3 times 2, which will give us 6. Then there's this sort of interesting one here. We do 3 double star 2. Anybody know what that might do? Why there's 2 multiplication signs?
The exponent, 3 square.
Yes, this is the exponent. So this is 3 raised to the power of 2, which when you run it, you'll see we get 9. Yep, good. Okay, so people are already kind of familiar with this. So we'll move through this a little bit quickly today. So one other note, if you want to clean up some of these cells in your workspace, you'll see here, this cell is selected in blue. On the left, you'll notice when I click in the cell, it's selected in green. So now I'm editing inside the cell. If you want to select the cell itself for cell manipulation tasks, you click out here again, it'll turn blue. So let's say we want to delete this cell. We want to click it, make sure we've clicked over here, so it's selected in blue, and then you press D on your keyboard twice to delete. So I'm going to delete some of these extraneous cells. All right. So with that, then we've been using scalar types. So just a couple of notes here. So programs manipulate what are known as objects. All objects in a program have a type that defines the kinds of things the programs can do with them. So for example, if we have a human named Anna, she'd be able to do things like walk, speak, program in Python, etc. Objects can be scalar or non-scalar. So in this case, a scalar object, what we're looking at is just pure numbers. These numbers don't have internal structures that can be accessed. They are just a pure value. We'll talk a little bit more about non-scalar objects later today. But just to give you an example of the different data types that are represented as scalars. So we've been working with integers, which is truncated to int in Python. So these are whole numbers, 3, 4, 5. This compares to floating point decimal numbers or floats, which represent real numbers with a decimal points of 5.1, 5.2. There's also Boolean types. So these are true false values. They can occupy two states, true and false. This will become important when we start talking about flow control later in this session. There's also the none type. This is special. It has just a value of none. So this is your null value. In other languages, if you're familiar with that. If you would like to see the type of an object, you can actually use the type command. So if we wanted to say type 3, press enter, it'll return the type. Let's say if we wanted to, excuse me, if we wanted to do type 5.7, sorry, we need this function. So this is a parentheses, we should enter. You'll notice we get float back. One important thing to note here is that we only get back the output of the latest thing we've done in the cell if we're using these, because each of these cells is an interactive Python shell. So if we wanted to see the type of both of these things, we would need to enclose these in print statements. And then you'll get the type out for both of these. And you'll notice that it sort of formats it differently when you print that out because the type function has a special print statement. But if you would like to see the output of various things over the course of a cell, you'll need to use print statements within it. Otherwise, you'll only get the last output in the cell. So in Python, in most languages, but in Python, we can cast types from one type to another. So for example, if we have an integer, or excuse me, a floating point number, let's say 6.7, and we need this to work as an integer, we can just say int 6.7, and what that will do is force the computer to treat this as an integer. So it will actually just cut off the decimal point. You'll notice it doesn't round, it just cuts off the decimal. What is typically more common is you need an integer to work as a floating point number. So let's say we have an integer of 6, and we need to add this to a floating point in a function that can only take in floating point values. You can just say float 6, and it will cast this into a floating point number. So we'll add a 0.0 to it so that it can be used with other floating point numbers. Print type hello. Yes, it should be a string. So let's give that a try, actually. So if we print type hello, you'll see, yes, we get class string back. We'll talk about strings in a minute here. So I'm going to go ahead and move on. So again, we're going to cover a lot of these things sort of quickly and not in a whole lot of detail. Again, the idea is just to kind of show you these things so you've seen them when they do show up in the workshop this week. So expressions then are a combination of objects and operators. So like we were doing before. So this 3 plus 2 is an expression where we have the object 3 and the object 2 connected by the operator plus. The expression resolves to a value, which also has a type. So in this case, it would resolve to the integer 5. And here, we have an example of 5 to the power of 2 plus 2 to the power of 2, all to the power of 0.5, returns a value of 5.3.5, so on and so forth. And you'll notice that even though the first part of this expression is using integer values, when it's raised to the power of 0.5 as a float, you'll see that everything gets automatically cast into a float. So sometimes Python will do some automatic casting for you. There are some programming languages where you have to specify the type of every single variable when you create the variable. Python is not one of those languages. It will try to resolve the type for you, which has its pluses and negatives. It means that you don't have to fiddle so much with defining variable types, but it also allows for type confusion here and there, especially once your programs start to get sort of complicated. So it is still important kind of to keep track of what your variable types are, even though Python does not require you to specify that up front. So again, some basic operators on integers and floats. The plus sign is summing, minus is difference, multiplication is product, and then the slash is division. A couple of special operators. We've already talked about the power operator. There's also an additional remainder operator. So if you use your percent sign, we do 5% 2. When we return, what value should we get here? So this is producing the remainder of 5 divided by 2. Any thoughts on what the remainder operator would be? Okay, Katrin says 1. Yes, we will get 1. So if we did this on 4, so this is known as the modulo or modulus operator. 4 modulo 2, we should get 0. And this will be useful in an example coming up later. So it's not always immediately obvious why this is useful, but we'll talk about it again in an upcoming example. Clear those out. Math calculations, operators do have order of operations precedence. So if you use parentheses, like most other programming languages, that gives top priority, and then you work with PEMDAS, exponent, multiplication, division, and then plus and minus interpreted left to right. So order of operations does apply. The easiest way to make sure that an equation does what you want it to do is make sure that things that you want resolved first are in parentheses. So we'll do 5 plus 2 times 3. Let's say divided by 4. And then let's enclose all that in the print statement actually so that we can keep that output. We get 8.5. And then if we wanted to make sure that 5 plus 2, let's copy those. If we wanted to make sure that 5 plus 2 resolves first, we would just add more parentheses around it. And say we want to do 3.4. And notice we get a different answer. Because again, it is prioritizing these parentheses first before the rest of the operations. So this should be pretty familiar to most people, either from previous programming courses or from early algebra classes. Just something to keep in mind that especially once you get into complicated equations, maintaining the order of operations, or at least remembering that it will do that, is important. So next big thing, we've been working just with kind of temporary expressions here where it's just resolving things one by one, but it's sort of the core functionality of programming languages, I would say, is the ability to assign values to variables. So this basically puts a placeholder in the computer's memory that allows you to assign a value to that variable, and that variable can be referenced again later. So for example, here we can say pi equals 3.14159. And then we can run the cell. You'll notice there's no output here because nothing is actually being printed. It's just created a space in memory for the variable. So we can come back up in here. We can say pi approximate equals 22 divided by 7. And then again, if we run this, there's no output because we're just creating these variables in memory. So if we wanted to see what these are, we would do print and then pi and print pi prox. And you'll notice when we print variables or when we print expressions, we don't use the quotations that we use for printed text. So when we run this, we should get the value that we set manually, and then the approximation of 22 divided by 7 produced as a floating point number. So again, when you divide two integers, if it doesn't divide cleanly into an integer, it will cast that into a floating point decimal for you. If this divides into a whole number, so if we were to do 21 divided by 7, we still get cast as a decimal. If we did want to force this into integer format, we could do it this way. And you'll notice it chops that decimal off. But again, that gets a little bit dangerous if you need to maintain that decimal, if it's not, clean division. Let's take that cast back out. Run the cell again. Got 2 questions in the chat. It looks like people are answering them for me. Yes, Kimberly asked, this memory lasts across the entire kernel, correct? Not just that cell. That's a very good question. So yes, cells below, cells above it can see what's been written in the cells above it. So the cells work kind of the same way that a programming text file would, where it sees from top to bottom. You'll see actually in the Jupyter Notebook interface, if I'm in a new cell and I type, let's say P approx, it'll highlight in the cells above it the rest of the examples of P approx. So it kind of tells you what it can see with that scope. All right, so I have a small activity here. You can change the values stored in variables. So once you've created a variable, you can reassign them later with future code. So up here, we've already defined pi. But let's go ahead and do it again. So we can overwrite this value. We'll do pi equals 3.14. Radius equals 2.2. Area equals pi times radius power of 2. You'll notice here I'm leaving a space between operators and objects. That's not required. It will also interpret it this way. Python will ignore the white space between operators and objects. Just stylistically, I like to leave a space because it's a little bit easier to read. And then we'll do radius equals radius plus 1. So what do we think the area is going to be when I run this code? Somebody could give this a run and report what they got.
I think it will be pi times 2.2 square.
Yes, it should be. But what is the actual value that it puts out for area? I mean, we've got 115 point. Yep. All right, so if I run this cell, nothing happens. I need to print area. Yeah, so that's the value you should get there. And if we wanted to see this variable changing in action, we could put in the print area here. We can run area again. To reassign, and if we print again, you'll notice we get another value because we've changed radius. Yes, spaces between objects and variables are ignored by Python in an expression. If you're looking at a string, the spaces are interpreted as a space character. Do you have a question here about how to change the precision on nanoHUB? I assume you mean the default number of decimals in your floats. That I'm not 100% sure about, but we can maybe find out later and let you know. All right. So just to keep moving on here, we have our last data type for today, which are known as strings. We talked a little bit about these already. So the string is a sequence of letters, special characters, spaces, digits. They're enclosed in quotation marks or single quotes. So we can say hello equals, I'm going to change this to greeting just to. You can concatenate strings. So concatenation basically just means joining two strings together. So we can say greeting and introduction. Let's just call this intro. Equals I am a program. And then we can say maybe hello equals greeting plus intro. And then again, we'll need to print hello. So we concatenated these two strings together. You'll notice that it did not leave a space between the two strings. So it just stuck the first string onto the very end of the other string. One way you can get around this, if you don't want to, you can add a space manually to one of the strings, and that'll maintain the spaces. But if you want each string to be self-contained and not worry about the spaces, you can add it manually here just by putting a space in between the two strings. So you can actually add a string dynamically into the concatenation, and that will do the same thing. That way, if you're trying to use a program to build a sentence, you can build those spaces in automatically in case you don't know exactly what's going to be put in each variable. You can also do operations on strings. So here we can say silly hello equals greeting times 3. And then again, we'll maintain our space and then plus intro. And when we print silly hello, we should get this repeated 3 times. So again, strings are just a data type that stores a sequence of letters, numbers, and characters. We'll talk a little bit more about strings in the next module and about how to manipulate them with functions. So again, we've talked about outputting the print with concatenation. We can also print numbers. So let's put a couple of spaces here. We'll do print greeting, so hello world. We'll add a space. Actually, we'll add a comma space. And then we'll say intro. number. Let's say we want to say, so this should print greeting or hello world, I am program number, and then 3, right? So if we go ahead and press enter, you'll notice you get a type error. So what that means is that we've tried to just add an integer type into our string, which we can't do. There's a couple ways to get around this. Again, with our typecast function, we can type or we can cast this directly into a string. So if we put str around our number and we run this, you'll get program number 3. The other way, Python has a built-in casting. Let me leave that there. Sorry. Just going to paste this down here. You can also use commas to concatenate data of different types. So if we run this, you'll get the same thing. You'll notice it added some extra spaces though. You take that space out. So if you do want to have a sentence output where you're not exactly sure what data types are going to be in what variable, you can use the commas to concatenate, and the Python interpreter will try to automatically cast things into the string. The question, how do I insert a space between the 3 occurrences and greeting 3? Yeah, so it looks like Sharon is going to address that in the chat. All right. So any questions so far on that? Let's take a minute to look at the chat. I want to make sure we have time to get to loops. So I'm going to work quickly through the comparison operators. All right, so it looks like people are doing pretty well with that. Again, if you have any questions in the chat, please feel free to drop them in. And I will make sure that each of these final notebooks are saved and uploaded to the course materials folder at the end of the day in case you wanted to go back and reference any of this code that we've built later. Yes, so Sharon is noting in the chat that if you would like to change the precision, you can use the round function. And she's included the syntax there. So next topic, we need to talk a little bit about comparison logic. So with the addition of variables and comparison logic, we're starting to get towards kind of the core functionality of a programming language. So you can use comparison operators on integer values, float values, and on strings. It works a little bit differently with strings, but we're going to look at ints and floats first. So what this does is it basically takes 2 variables, it compares the 2 values, and it evaluates it to a Boolean result. So like we were talking about before, true or false. So it returns a true or false value for each of these things. So you can use less than, or yeah, greater than or equal to, less than or equal to. So there's a typo here in the third one. That should be a less than symbol. We also we have an equality test to see if 2 values are the same. You'll notice use a double equals for that. Our single equals is reserved for assigning variables in Python. You have to use your double equals to test if things are the same. And then you have the inequality test, which is exclamation point, or sometimes called the bang equals, which is your inequality test to check and see if things are not the same. So if they're not the same value, it will return true. If they are the same, it will return false. It's the opposite of the equality test. Again, the slide here on logical operators on booleans. So you can also use the not function. We'll look at that a little bit in our loops discussion. I'm going to go ahead and actually skip this table. We can also combine logic with and or. And we'll walk through a couple of examples of that in a minute. So actually, let's take a look at that now. Losing track of my slides here. Let's just go ahead and test this out. I equals, we'll say 5, j equals 7. If we do I is greater than j, you'll see we get the output of false. If we switch this to I is less than j, we'll get true. Again, if I double equals j, false. I is not equal to j, true. And you can actually store these values in a variable if you need to use them later. And we'll talk about in loops why you might want to do this. But we can say test result and again, because we're storing this in a variable, you'll notice that we don't have an output because we then need to print test result. Sorry, using the old syntax still. And when we print it, we'll see we get true because I is not equal to j. Then we can change I up here. So if we change this to 7 and run the cell again, now we get false because they are equal and we're testing for non-equality. Change this back to 5, run it again. Now what this allows is it opens us, you explain that again, test result, when is this used? All right, so what we've done here is we've just taken the resolved expression I not equal to j, which again resolves to true because they're not equal. Let's maybe actually make this equal just to kind of make the logic a little bit easier to understand. So I is equal to j. The result we get here is false. These two values are not equal. And all we've done is just store that in a Boolean variable called test result. So now test result has the value of false. And we can use that later in our program if we wanted to keep track of the results of these comparisons. Yep. All right, so to talk a little bit about control flow, this is also known as branching. This is where we get into our if statements. So a lot of times in programs, you will need to make a decision throughout the program about whether to do one thing or another thing. Again, we call this control flow, and we use the if statement for that. So say, for example, we have I equals 5 and j equals 7. So if I is greater than j, we want to do one thing, and if it's less than j, we want to do another thing. So we would say if I is greater than j, then we'll do a colon. And then you'll notice in Jupyter, after a colon, when you do a carriage return, it will automatically indent for you. So indentation in Python is very important. Anything within an if statement, within a loop, within a function definition, within a class, indentation indicates what is within that block, essentially. So let's say if I is greater than j, then we want to print I is greater than j. So we'll press enter. You'll notice it's maintaining the if structure. But we want to exit the if because now if I is less than j, we want to print I is less than j. In this case, we'll say else. And then we'll print say less here. So when we run this, we should get I is less than j because I is 5, j is 7. What the else is doing here is acting as a catch-all. So basically it's saying if I is greater than j, we print I is greater than j. If anything else is true, or in any other case, we print I is less than j. Now you can imagine that there's a couple of situations here where we may want to say other things. So if they're equal to each other, we need what's called an else if. So we would say else if I is equal to j, we would want to print I is equal to j. So what this will do is it'll first check to see if I is greater than j. It'll then check to see if I is equal to j. And then if anything, if neither of those is true, it will do the else. So if we run this, we'll see we still get I is less than j. Let's make I equal to j up here. I is equal to j. Let me actually just move these down again. So something important to mention, if you change a value in a cell above the cell you're currently using, you have to run that cell again for that value to be updated in the cells below, which is why I've moved these down. Just makes it a little bit easier. That way you only have to run one cell at a time. If we change I to 8, we get I is greater than j. Now, good programming style, especially if you don't know exactly what's going to happen, if you're taking any kind of input from the user, you would want to do this in a little bit more of a structured way. So we would say we'd first check to see if it's greater, then we'll check to see if it's less, then we'll check to see if it's equal, and then you'll have kind of a catch-all print statement as your else, which would say, I don't know what happened to your numbers. Because in that case, we're not sure what's going on. So if we run this, we'll see I is greater than j. If we change this to 5, I is less than j. If we change I to 7, we should get I is equal to j. And then if we change I to the word 7, sorry, when you're defining a string, you need quotes. We'll get an error because we can't compare string with 7. Yes. So in this case, you'll get a type error because we're trying to compare two different things. But the idea here is to have a catch-all else statement that prints something in the event that the conditions that you were anticipating were not met. We do have a good question how to exit if, to write else if. You would just use the break command, and we'll talk about that in a minute in loops. That's a very quick overview to the if statement aspect of control flow. So again, remember your blocks and indentation. So here we have our blocks. You can have multiple lines in an if statement, obviously. You can even have nested if statements. So if you check and something is true, and then you need to do a couple of different things depending on what the value actually is, then you can nest your if statements. But again, a nested statement would look like this. So you would also need to indent. Sorry, you don't need to indent the if. You would do if. So let's say we want to see if I is an odd number. We would say if I divided by 2 equals 0. So what this tells us If we can divide by 2 and it equals 0, it means the number is even. So let's say we print and I is even. So if we run that, you'll notice all we get is I is greater than J. But if we change this to an 8, which is now even, we'll get I is greater than J and I is even. So you'll see it only prints out in the case that it's even and I is greater than J. If we drop this down to 6, we only get I is less than J because it's going straight to this line and it's not running this evenness check. So again, we talked about this. Single equals is to assign variables. Double equals is to compare them. So I think I actually kind of just spoiled this activity by showing you this code, but we are running a little bit behind schedule. So I think we'll skip this here. Please feel free to come back to this slide later and try it on your own. But what we've done here should cover this. So let's talk briefly about loops. We need to run over by just a couple minutes here, but module 3 today will be a little bit shorter than the rest of these, so we can move some of this stuff back. We'll make sure to respect our breaks today. So a little bit about control flow with loops. So between if statements and loops, this is kind of the basis of how you can tell your program to move through different procedures. We'll talk about 2 loops today, a while loop and a for loop. A while loop basically runs a block of code repeatedly until a certain condition is met. So let's say while when equals false, and then what we'll do is set up a little fake game. So that we'll print let's change this to lose actually. While lose equals false, while player has not lost a game, we'll print player is still in the game. Now it's important while we're working on while loops not to run the cell until we have set up a condition where lose would become true. If we run this cell now, we'll have what's called an infinite loop. Let's say lose equals false up here. If we run this now, nothing's ever happening that changes the value of our variable lose. So it will just print player is still in the game forever until we forcibly interrupt the cell. So don't run this cell yet because we need something that will change lose to true. Okay, this example is not good, I'm realizing. So I'm sorry, this is what I was mentioning before. Sometimes programming gets a little confusing. I'm gonna get rid of this. So let's say while, let's make a variable called x, set that to 0. While x is less than 10, we want to print the value of x. This is a much simpler example. Jump the gun with the other one. And now we're not going to have the infinite loop situation. We will actually, because we need to increment this. So we need to add x equals x plus 1. So now when we run this, you'll see we get the value 0, 1, 2, 3, 4, 5, all the way through 9. It stops at 9 because we run, when it starts at 0, we add 1, continues up until 8, 9. It runs on 9 and then adds 1, but then when it comes back around to check while x is less than or equal to 10, It is now 10, so it does not run the loop. It exits the loop. We can include the 10 by doing less than or equal to. You'll see it puts out the 10 because it still runs when x is 10 and then stops. So, simpler example. Sorry about the game example. Hopefully this one was less confusing. You'll notice here that we had to create a counter for this while loop in order to avoid that infinite loop situation. We can shortcut that by using what's called a for loop. So we can say for, and then we give a temporary counter variable n, and then here we can specify range 10. We can print n. And you'll notice we get 0 through 9. So a for loop will run up until the index of n minus 1. So it starts at 0, n is instantiated as 0, and then moves through until it hits the end of the loop. So we will be using a lot of for loops next week in our workshop. The for loop is kind of the standard way of indexing through a list in Python, and we'll talk about lists in the next module. Yep. So again, n is being updated each pass through the for loop as an index. So when do you use while loops versus for loops? Actually, I have a slide about that here in a second. So for loops they're more efficient when we know the number of iterations that we need through something. So if you need to pass through a list and look at each item in the list and do something depending on that value, that's when you would use a for loop. You can end it early via a break if you need to, so you can break out of a loop. So we can actually, if we do if n equals 4 and then break, when we run this, sorry, made my own mistake there. You need a double equals. If n equals 4, then break, so it will stop the loop early. There's another command that's sometimes useful called continue. So we would say if n equals 4, here you would print this is where n equals 4. And then you can say continue. I can spell it right. And what this does is instead of stopping the loop, it will actually just move on to the next iteration and continue the loop. Put that break back in more illustrative. So it uses a built-in counter. So this is mainly for iterating through lists of data. You can rewrite a for loop using a while loop. You cannot always rewrite a while loop using a for loop. While loops are for an unbounded number of iterations. So this is when something needs to run repeatedly, but you don't know exactly how long it needs to run. You can also end it early with a break if certain conditions are met. You can use a counter, but like we did up here, you have to initialize it ahead of time. But you don't have to use a counter as your condition. So a while loop is checking for when a certain set of conditions is met in a program before it moves on to the next block. And you can use this for things like when you're taking user input, you use a while loop until the user has provided the input. There's a number of different ways that you can use the while loop, but the main difference is that for loops are for bounded lists of iterating through and doing something at each point in the list. And a while loop is for when you need to run a certain chunk of code until maybe a larger set of conditions is met. If that helps answer that question. All right, so we talked about the break statement. We have an activity here. I think what we'll do is we'll go to break. It's about 11:30, so we're 3 minutes late into our break. We do need to have our module questionnaire. I don't know, James, if you've got that ready. So what we'll do is we'll put the questionnaire up, assuming we have the questionnaire ready. People can go ahead and fill that out, and then I'll put the activity on the screen. If anybody wants to work on it during our 15-minute break, they can do that. Otherwise, the slides will be available for reference later. And then we'll move on to lists and sequences next. So we have our module experience questionnaire. Please, everybody, do respond to this. It helps us determine what needs to be changed for the next time we do this, and to get a general feel for how the session went. So we'll give people a few minutes to do that. And like I said, I will put, oh goodness. Our loop activity up on the screen while we take our break. So if you want to give this a try in the next 10 to 15 minutes, we will come back at 11:45 for our next module. And please do still feel free to add your questions to the chat. I'm going to step away and grab some water for a minute, but we'll come back and people in the TAs in the room can continue to help answer those questions.